I'm Anil Kumar, and now let us discuss rate of change for polynomials. The question here is, select either preceding or following method or difference method to verify whether the point given is maximum or minimum for the following function. Draw a curve with the instantaneous rates of change around the maximum or minimum point to prove your findings. The polynomial given to us is p of x equals to minus 2x squared plus 4x plus 16, and the point given to us is 1, 18. Now this is a knowledge-based question. It really reviews the whole concept. When we are saying that this polynomial has maximum or a minimum at the given point, which is 1, 18, it really means that the instantaneous rate of change at this point should be 0, which we can find using the two methods mentioned here. So let us explore and figure out whether it is a maximum or a minimum. Well, to start with, it's a parabola, negative leading coefficient, right side down, so we are expecting a maximum, right? So this is what we are expecting, and let's try to prove it. So what we will do here is we'll do preceding following method and then show our calculations for the same. So we already know what is p of 1, which is 18. So it's like this. Let us say that is the number line, and we are just considering a point which is at x equals to 1, right? So we'll take 2 points, one on the left side and one on the right side of 1. So let this point be 0.99, and on the right side let's take the point 1.01. So we'll find the value of the function at these points. So what is p of 0.99 equals to? So that is minus 2, 0.99 square plus 4 times 0.99 plus 16. And let's use the calculator to find the answer. So it is minus 2 within brackets 0.99 square plus 4 times 0.99 plus 16 is equals to 17.998. Now we know the value of the function at 1 is 18. That's given to us. So let's find the value of this polynomial at 1.01. Remember, this distance should be same on both the sides. So that is to say it will be minus 2 times 1.01 square plus 4 times 1.01 plus 16, right? Let's plug the values and find the answer. Minus 2 within brackets 1.01 bracket close square plus 4 times 1.01 plus 16 is equals to 17.998. So that is also 17.998, right? So we have the values of the function at 0.01 point left and right of the given point. Now the rate of change, preceding rate of change, is how much? Let's calculate. So let's find instantaneous rate of change, and let's say preceding, right? So let's say p before should be equals to f of 1 minus f of 0.99 divided by 1 minus 0.99, correct? So this value for us is f of 1 is 18, so it is 18 minus 17.998 divided by 1 minus 99 is 0.01, correct? So we can calculate this value. So it is 18 minus 17 point, actually it is 998 divided by 0.01. It is 1 over 50. So it is 1 over 50 for us, correct? Let us also calculate the following. So let me do it on the right side, okay? So the following is, so we'll say rate of change for following, that is f of 1.01 minus f of 1 divided by 1.01 minus 1, correct? So this gives us a value of, now 1.01 is 17.998 minus 18 divided by 0.01. Now that gives us a negative answer. Do you see that? So it is 18 minus the number, it is 17. So of course this is negative 1 over 50. So what we notice here is that the rate of change at a point on the left side is positive, right? That is the preceding one. So it's kind of positive rate of change here. But immediately after it is negative. So that's the rate of change. So in between, what is the rate of change? You add them, divide by 2, right? So the rate of change for us is, so we'll say, we will say the instantaneous rate of change at x equals to 1 will be average value of these two, right? So which is 1 over 50 plus minus 1 over 50 divided by 2, which is equals to 0. Now the instantaneous rate of change in the center is 0. So in the center it is 0. It means that there is either a maximum or a minimum. It means it is a turning point, right? It is a turning point. So that means this. Now whether that turning point is a maximum or a minimum, how do we find that? Since the preceding is positive and the following is negative, so that it's changing from positive to negative, therefore it is a maximum. Do you understand? So that is how we have to prove it. So therefore it is a maximum. Since the rate of change changes from positive to 0 to negative. Do you see that? If that is the kind of rate of change around a point, then at that point we have a maximum, right? So that is what we're trying to understand. And of course, the parabola will have a vertex here, so it's going to be kind of like this. I hope with this the concept is clear how to find or verify that a point represents a maximum or a minimum. Thank you and all the best.